Welcome to the Insightful Professor. In today's discussion, we're going to continue our examination of classes, and specifically, we're going to be looking at something called class inheritance. Remember that a class is a data type, and what that means is we study or analyze the application or problem domain, and from our understanding, we then come up with a description of how to represent a particular entity from that application domain. Effectively, that defines the class. We then instantiate objects. So a class is used then to define the subsequent objects or instances that will be used within a program as we manipulate these representations of these real-world entities. Now, when a class is defined, it describes characteristics of a whole bunch of things, a group of things. Each is then going to be defined by a common set of attributes, the structural characteristics, what are the properties of these things, and each will also be accessed or manipulated through a common set of operations. How do we interact with that structure? Give you an example of what I mean. Let's take a look at the concept of something called a box. A box is a general concept. We have all kinds of boxes that might be out there. But looking at the common set of attributes, we say, well, a box has things like dimensions. A box has a length, regardless of what kind of box we're referring to. A box has a width. A box has a height. And maybe various other attributes or characteristics that in general are possessed by every box. But also a box has a set of operations or functions that can be performed. And these are applied to any box object. They allow us to operate on the box by doing things such as filling the box, emptying the box, examining the volume of the box, or computing the surface area of the box. So again, these are common attributes and common operations. They're common to all instances of box, regardless of what type of box we might have. So this brings us to the next point. We talk about generalization, which is exactly what we were describing there. In general, every box has these attributes or features. Every box supports these operations or this type of behavior. But we also get to the concept of what's called specialization. In the real world, there can exist many types of boxes, and our computer programs then model and represent these real-world entities. We represent boxes in some way in our particular example. But in the real world, we also recognize that's a generalization, but there are specific kinds of boxes. For example, a box is the general concept. They all have the attributes and the behavior we just described, but we could have something like a candy box, a cigar box, a moving box. They'll all share those common characteristics and common functionality, but they'll have distinguishing characteristics that are unique to their particular type or particular variety of box. So when one object is a specialized version of another, we mention this thing called an is-a relationship, such that a candy box is a box. A cigar box is a box. And this gives rise to the concept of something called inheritance, because whatever is common is then inherited by everything that is one of those things. So an is-a relationship effectively captures the notion that a specialized entity is a kind of a generalized entity. A candy box is a box. A cigar box is a box. And these specialized boxes all have length, width, height. They all have the ability to fill, to empty, compute volume, compute surface area, and so forth, regardless of the fact that they are specialized things. But the key is that the specialization allows us to extend the capabilities or the description that every box has this in common, plus a cigar box has something additional, or a candy box has something additional. So other examples we'll see that fall within this, say, concept of the is-a relationship and inheritance. In addition to our variety of boxes we've mentioned, we could say a poodle is a dog. A car is a vehicle. And again, the poodle would be the specialized case of dog. All dogs have certain characteristics. Poodles share those. But in addition, poodle has additional things that maybe would not be common to all dogs. And likewise, a car is one type of a vehicle, but there are other types of vehicles. For example, we might have a motorcycle. Cars and motorcycles are both vehicles. There will be certain things they have in common, but there will be things that a car has that a motorcycle doesn't have, or things that a motorcycle has that a car doesn't have. And again, that's the notion of specialization. But at this point, we're talking about getting all of that commonality within this specialized feature or specialized object. This is called the is-a relationship. Now, the is-a relationship is something that's been around for quite a while. In the field of artificial intelligence, or AI, this notion was presented as a semantic concept in describing things that might exist in the real world and looking at inheriting those characteristics. That's exactly what we're doing here. But the is-a relationship is now being used in object-oriented analysis and design, also used in database analysis and design. So the concept is not specific to looking at just, say, Java programming, but it's broad within the whole object-oriented paradigm and in database and other disciplines as well. So what are the benefits of inheritance? Well, software designers have the ability then to build new modules, effectively classes, on top of existing classes. So I define what a box is, I build the characteristics of that, and then I do the specialization and basically extend that definition or enhance it to define a candy box or cigar box or something of that sort. The benefit then is there's no need to redesign and recode from scratch, because effectively what we're doing is reusing something that's already been defined or established. So the new classes are said to inherit the behavior or the operations or the functionality of the thing from which we're deriving our new definition, and they also inherit the structure or the attributes from the thing that we're doing our inheritance from. Okay, so the inheriting behavior enables the concept of code sharing and reusability. This is a key concept in object-oriented programming. The inheriting representation enables the sharing of the structure among these objects. So inheritance provides what we would consider kind of a natural mechanism for organizing the relationships between various types of things in our real world and within our representation as well. Now, the fun part, terminology. Inheritance is the means by which a new class can be defined in terms of previously defined classes. That's a simple definition. But what is it that we're inheriting from? We're inheriting from something called a base class, also very commonly referred to in Java as a superclass. That's the thing that's established first. That would be the generalization, the box. Then we develop something called a derived class, whose definition is derived from this base class. Alternatively, we can refer to it as a subclass. Again, a very commonly used term within Java. The idea is that the base class is our general class, and it defines that commonality to which we referred a moment back. So the derived class is the specialized class. It basically is extending the definition, adding additional characteristics or additional functionality. So the derived class is based on or derived from the base class. Hopefully that's not too overwhelming, just a couple of terms here, but we're going to add more. The derived class inherits member variables and member functions from the base class. This is where we get that reusability. There's no need to kind of reinvent the wheel. We just take something that's already been established and we apply it automatically through inheritance into our subclass or derived class. But we also can extend it to add new member variables or new functions, extend the behavior as well as the structure. And that's the specialized characteristic of this subclass or derived class. Now, because inheritance can be thought of as well. I inherited this particular attribute from my parents. Well, the idea is we often use the terms a little less formally, the concept of a parent and child type of relationship existing between the base class or superclass and the derived class and subclass. So parent-child is also another term that's used, a little bit less formal, but still nonetheless used in discussing notions of inheritance. So generalization and specialization, in a little bit more detail, we say that real-life objects typically are kind of specialized versions of something that's a little bit more general. For example, we might think about something like an insect as being a general concept, but we can also come up with specific instances of insect, such as a grasshopper or a bumblebee. These specific instances have all of the general characteristics or properties or behavior exhibited by an insect in general, but also kind of show their specialization. For example, a grasshopper has the ability to jump. A bumblebee has a stinger. So what we see is that these are extensions to grasshopper and bumblebee as being specialized types or forms of insect. Everything that an insect in general has, a grasshopper will have, a bumblebee will have, but these are some of the specialization or specialized characteristics. So here's how we might depict it in the notion of inheritance using a form of a UML diagram. Up here we have the base type, insect, and we say, well, that's where the commonality is. Then bumblebee basically derives from that, grasshopper derives from that, and that's where we see the specialization and the extensions in terms of additional attributes that are unique to bumblebee or attributes unique to grasshopper, or behavior unique to bumblebee or unique to grasshopper. But notice the idea is that the subtype or subclass refers to or points to the superclass. That's the notion of the UML diagram signifying inheritance. So how do we implement an ISA relationship? Well, when we do this, we've already mentioned various examples of what constitutes an ISA relationship from some problem domain. But what we're going to do is note that we're going to establish a relationship between these two classes, the subclass and the superclass, or the derived class and the base class. In Java, this is accomplished by using a keyword called extend. So when we go ahead and define the subclass, we say that the subclass extends the base class. So the base class obviously must already have been established or defined, and then we are going above and beyond that. First off, we're inheriting everything, and then we may choose to add additional structure or behavior in addition. So the derived class presents then the ability to establish this kind of a natural hierarchy, kind of grouping things of similar characteristics or behavior together. So in a company, we might talk about things like employees. But employees, we recognize there are different kinds. Some of the employees get paid on an hourly basis. Some are salaried employees. So clearly we can see some kind of difference. We're going to see generalization that every employee must provide to us, say, a first name, last name, date of birth, maybe social security number, things of that sort. Every employee has that. But then there's a distinction as to how we might pay these employees or other responsibilities for employees that will make them kind of subclasses. So we could then qualify this and say I could have an hourly employee, I could have a salaried employee, and that's based upon this distinction here, or this kind of specialization. So all employees have the common characteristics that we mentioned. So an hourly employee gets paid an hourly wage. A salaried employee gets paid some kind of fixed amount, regardless of the number of hours that he or she works. So again, this is some way that we would have to make a distinction between these two subclasses. So again, also the behavior would be, how do you calculate their paycheck? Well, it's going to be a little bit different for someone who's working a fixed number of hours or a flexible number of hours and they get paid an hourly rate versus someone who just gets paid a flat rate as a salary. So as an example, we talk about these classes of employee, and we say there's our base class. We extend that to define hourly employee. We can go further and say part-time hourly employee, and just keep going and going and going. And that's the notion of the hierarchy we were talking about. But as we go from employee to hourly employee, the hourly employee inherits everything that an employee has. If we were to then go a step further and go part-time employee, or say part-time hourly employee, a part-time hourly employee would inherit everything that an hourly employee has, some of which would be inherited from a regular generic employee. So let's look at this with some code and a bit of an example. We're going to say in general that the subtype of hourly employee will extend whatever base type or class we're inheriting from. So we would say hourly employee is going to extend employee in general. So when we have a derived class, it's said to inherit, again, the instance variables and the methods that were defined within the class for which it is being an extension, or for which it is extending. That's the base class. So class employee defines name and hire date, so hourly employee would get name and hire date. Those things would be inherited. Okay, let's take a look at this in action. I'll go into my IDE and show you a little bit about this, how it works. Okay, so here's the code for employee, what we're calling our base class. We define it as a class. We say, here we are, employee, and then we have attributes or member variables or fields that define the structure. This is a very simple example. This is not very well defined in terms of integrity. We simply want to illustrate the basic ideas of what constitutes a base class, what constitutes a derived class, and how inheritance works. Obviously, we would want to do much more to enhance the integrity of this. But let's assume that we say we've got this no-arg instructor, kind of a default constructor, and we simply say we're going to assign to the name, no name. We're going to assign to the hire date this character string. We're making them both strings just for simplicity. So that's what would happen if you just instantiate an object and this constructor is invoked. But we also have kind of a value-based constructor where we can pass it the name and the date, the two strings that represent the values for the member variables. And we simply assign those. No data validation being done here. Again, it's just simplistic to show you the idea of basic inheritance. Okay, then we've also got a copy constructor. We've got our getters and setters, and again, with the setters, we make no attempt to enforce any kind of validation or data integrity. But that's the basic idea of the base class. Now, we go ahead and define the hourly employee. The hourly employee is said to extend employee. So here's our base class of employee, and here's our derived class of hourly employee, and extend is part of the Java syntax that says this is what we're starting with, the base class, and we're adding to it in some way. So notice what we're doing in this case is adding two additional attributes. These attributes are not going to be part of every employee object, but only the hourly employee objects. The hourly employee objects will inherit things like hire date and name, but the hourly employee will also add hours and wage rate. So here's our no-arg constructor. We'll talk about this in more detail, but we have to invoke the base class constructor to ensure that those attributes we were talking about get created and a constructor is executed to initialize that storage in some way. So in order to ensure that that happens, when you instantiate an object of a base class, instantiate an object of a derived class, the base class constructor has to be executed. So here we're explicitly invoking it, by calling this thing named super. Super is a keyword or reserved word that says you're calling my SuperClass constructor. So that's the first step. Then with that storage, what happens is this storage gets allocated and initialized. So what is actually happening is kind of interesting. We can think of the idea then that when you create a base class object, you're really creating an employee object that can be thought of as almost being contained within this base class object. But this guy has to be brought into existence. So that's where this super constructor invocation comes into play to allocate that storage and initialize it properly. Now again, simplistic examination here. We're just saying here's a precondition. We're just making this assumption. So there's no data validation or integrity here. Just a very simple example. So here's the overloaded constructor where we're passing values. Notice that what we're passing is we're passing something for the name and the date. Even though those attributes are not explicitly defined within the derived class object, they are inherited by the derived class object. Hence, there will be storage there. So we have to provide those values. And what we're doing is we're taking the values that are used when this particular constructor is invoked, the values for the name and the date, and then we're relaying those or passing those to the base class constructor by invoking the overloaded or value-based constructor that we defined for employee. And again, the first case, we invoke the no-arg constructor simply by saying super and having parentheses. In the second case, we're invoking this other constructor by saying super and then providing these two values. Now, where do those values come from? That's exactly what we were just looking at. They are passed in to this overloaded hourly employee constructor and then relayed over here to the base class constructor. Then we do what we need to do after the base class constructor has run. Then we do our part within the derived class constructor. Okay. We also have a copy constructor here, and then we have additional extension where we're showing the additional attributes and the methods to deal with these. The getters for hour and rate, and the getter for pay, and also the setters for hours and rate. And then we also use the toString and equals, something that is we've discussed previously as being something necessary for functionality within classes and objects. So with that in mind, let's go and look at a simple example to utilize this. So here what we have is an example called inheritance demo, and it's an application. We've got the main method, and what we do is we say I'm going to make an hourly employee. I'm going to call it emp, and then I hit the new operator and invoke that overloaded constructor. Notice in the overloaded constructor, I'm giving it the name Joe Worker and January 1st, 2004. Those are attributes that will be placed within the base class member variables, kind of the base class part of this derived object. And then these are the two that are going to be going into the hours and the hourly rate. Okay, then we simply say emp.getName. So emp is our reference variable, and we're simply invoking the getName member method. Where did getName get defined? Not within our employee, but that's one of the methods that was inherited. That's in the employee base class. Okay, then we're doing the setName, and we're also simply dumping out the employee itself, basically looking at the toString to tell you what's in there. So let's fire this up and see what we get. Okay, I'll bring this up, make it a little easier to see. And when we fire it up, here's the output. So that's pretty much it. We haven't gone into the real details of how this works, but we've given you a very quick overview to the concept of defining a derived class from a base class and getting a little feel for what's inherited and how it works. We'll go into much more detail with additional videos, but this is a quick introduction. I hope you found this useful and informative. Offer some comments, suggestions in the comments section below. And once again, thanks for watching.